I got a phone call from someone who, it was like what I call a cold call, like I don't recognize the name that comes up on the screen. It was a fellow who was telling me that just 2 weeks before, his Strawbale home that him and his wife and their 4 kids lived in had suffered a roof fire. So he was calling Strawworks to see if Strawworks might be able to do an appraisal on the house to figure out like what they could get for an insurance claim. But right away I was just really impressed by how well he talked about how the bale walls like withstood the flames. This fire broke out in the roof and the roof completely burned, but like the bale walls never caught on fire. And even more than that, his line of work is fire remediation. So it was like a perfect, yes. It was like, wow, this guy really knows fire, and he's a great person to speak to about this. So yeah, his line of work is they go in and they fix houses where fires have gone through. And I'd never been to see a bale house where a fire had gone through, and as a bale builder, I always wanted to. So a couple weeks later, I hopped in the truck and drove down there. It was pretty devastating, and really devastating to be standing there with the homeowners and just to have their lives like ravaged. And basically what happened was they had like a satellite for internet like out on this end, and this is like a really windy part of Ontario with Lake Erie just being like a kilometer away. So the wind ripped off the satellite dish and it left an arcing wire, caught the roof structure. The structure of the roof was particularly combustible in that it was parallel cord trusses, and the way that it was built in the end, there ended up being like a 5-inch airspace as part of that assembly. So once fire caught on this side, it just like ripped right through. This was really sad. This is the great room. There's Greg. There's Greg again. So this is where the story starts to pick up a bit, because he was just so impressed with how the bale walls withstood the flames. And so here he is like showing like, you know, golden straw that was never affected. And that roof burned for 8 hours. And in those 8 hours, like the bale walls never caught on fire, and they didn't contribute to flame spread. They weren't affected by the radiant heat. That's another way that things get damaged in fires, is just the crazy radiant heat that comes off the fires. So all in all, they performed like super well. That's looking down at the top. Eventually, the box beam on top of the bale wall did burn, and then the top surface of the straw was charred a little bit, and then, you know, the rest of the house still standing. So so here's where the story takes an unfortunate twist. So you can see that right here, like the plaster is all beaten up and bashed open, and it's like, what happened here? And what happened was the volunteer fire service department that came to this fire had no idea what Strawbale construction was, read in the newspaper about it, and one guy's like, yeah, I Googled it on my way. So had no idea, and they had, unfortunately, sort of the exact wrong reaction. As soon as they heard Strawbale, they thought like, oh my God, like this is going to be the worst fire ever, and we have to like get in there and get at that straw to prevent like the walls from catching on fire. So they actually bashed the plaster and broke the wall's fire resistance rating. I should say that, like, backing up a little bit, like when Greg was talking about how well the bale walls perform for fire, it's like it's great to see that, and that's not surprising because bale walls have a 2-hour fire resistance rating. So you know, loose straw is super combustible, and it's a danger on the job site. It will go up quickly. Bales, much less so. They don't contribute to rapid combustion. Like the outside will light, but it'll take a while for the full bale to catch on fire. And then by the time you have incombustible skins on both sides, that in combination with a core that doesn't burn well, you have a very fire-resistant wall. One that has a 2-hour fire resistance rating, so it surpasses what code requires for Part 9 for residential and low-rise, which is 45 minutes. But the problem is that, you know, this fire department and most people don't know that. So they had the wrong reaction, and they started bashing the plaster on the inside and the out, which, yeah, is exactly wrong. Now, sort of like no fault blamed, right, because they're just trying to do their job, and they're already pretty limited what they can do as a volunteer fire department. They're not allowed to go into the house unless it's to rescue somebody, and they couldn't even go in to like break open the ceiling and spray the flames directly. And because it was a metal roof, they weren't equipped to cut the metal from the outside. So their hands were sort of tied. Like all they did and could do was bash the windows and put the hose through the windows and try and like soak everything. And they were working as hard as they possibly could. There was a long fire. They were there from like 10 at night till 6 in the morning. Probably the house couldn't have been saved anyways because there's so much smoke damage and water damage. But I think it calls for like an education campaign and for, you know, Strawbale construction houses and how they work to be introduced into their training modules, because it would have been great if they were like, oh cool, it's a bale house, like we don't really need to worry about the walls, you know, like they're not going to catch on fire, and yeah. Instead, like they had exactly the wrong reaction. But that's not what, you know, most people, when they think of straw, they think flammable. Often volunteer fire departments come from rural areas, and what do rural people know of straw? Well, they, you know, a lot of people confuse it for hay and think like spontaneous combustion, which again, yeah, occurs in hay bales, but not in straw bales. And also, a lot of farmers still burn waste straw. So most straw in the States is burned annually still, just to get rid of it. So that's like a whole other problem and contributes to a lot of particulate pollution and carbon emissions. But yeah, I read a statistic that enough straw is burned in the U.S. every year to build like 2 to 3 million homes. So it's a huge amount. So I'm just going to show you the news clip here.
A family in Wainfleet escaped a fire last night that destroyed their home. Fire officials say it was a relentless blaze and several factors made it a challenge to put out. Kelly Botello has the details.
Fire ripped through this home on Side Road 18 in rural Wainfleet, north of Port Colborne, at around 10:30 last night.
We got on scene, the fire was well entrenched in the roof. We have a steel roof on the building that's making our operation difficult.
2 adults and a teenage boy managed to escape the blaze unharmed, as well as their 2 pet dogs. At the height of the fire's intensity, 15 firefighters from Wainfleet and 5 from Port Colborne were working to put out the stubborn blaze that was extra challenging because they were dealing with a straw bale construction home, meaning the insulation in the walls was made of highly flammable straw. And because the home is on a country road, Wainfleet Fire needed backup for water supply.
We've got mutual aid tankers from Port Colborne and from Haldeman assisting us. We also have a crew from Port Colborne assisting us with manpower. We have a pond across the road that we're also taking water from.
The shell of the home is still standing, but the interior is destroyed. The cause of the fire is not known at this point, but fire officials say it does not appear to be suspicious in nature, adding that the homeowner believes it may have been caused by an electrical box near the peak of the roof. The fire marshal will not be called in to investigate, as the blaze caused less than $500,000 in damage. Firefighters were called back to the home this morning to put out a hot spot nearly 10 hours after the blaze began. The deputy chief saying this was a challenging fire to put out, mostly because of the way the home was constructed. Nicole.
Just drive that point home, you know, like.
I noticed they did say the shell was the only thing left.
Yeah, exactly. So, you know, as per usual, the media got it totally wrong. Yeah, I know they didn't say like why it was extra challenging, just that it was because of, you know, it being Strawbale construction. So
the firefighter only mentioned the steel roof.
Yeah. I actually, I thought earlier in the week, wouldn't it be fun if, you know, Jen and I got up and did a little skit right now of like the good news story and, you know, how it could have been like success story, like, you know, Bale walls didn't burn and it was great because it bought the fire department all this time and they didn't have to worry about the walls collapsing, but that's not how it went. So the house is destroyed, and when I met with them, we went over sort of options of, you know, rebuilding, and I was trying to make a case for just going back to the original plans and just rebuilding the house or the sections that needed to be as is, but due to basically not any Strawbale builders down there, they ended up taking it down to the foundation, and they're right now rebuilding like a double frame insulated with Roxol house. So to some degree, in thinking about house fires and Bale walls, because this is the typical story that when a fire breaks out in a house, pretty much like the house is destroyed. And so building code is not really concerned with does it burn or not. It's just, yes, everything burns, like we build with a lot of wood in this part of the world. It burns, and the question is, can people get out? So it kind of, I had a moment of thinking like, well, what's the point then? Like, you know, if it's just going to be destroyed, like, is it really an advantage that Strawbale construction has a 2-hour fire resistance rating, and is that something that really kind of works out in the end, or does everything just get knocked anyways? And, you know, as Greg said, the homeowner, like, the walls never added to the fire, so that's huge, right? And because normally how a fire goes is like the fire will catch in one part, and then it'll catch this wall on fire, and then that wall on fire, and then the whole thing just goes up in flames. And Greg said, like, if this had been a conventional house, like, everything just would have been ash. So, and I think, like, there's maybe other people in the room that can speak to other Bale houses burning in Ontario, but, like, I think there was one in, like, the Killaloe area where, like, sorry? Pembroke, okay. Yeah, and as what I know of that one is, like, maybe you know more, Cheryl, like that the chimney caused a roof fire again? Right, yeah. And again, with that one, what I heard was, like, the roof was gone, but the Bale walls were left standing. So then, ideally, you would think, like, cool, let's just rebuild the roof. But unfortunately, the Bale walls are so damaged from smoke and water that doesn't happen. Greg did say, I called him this week, that when they did demo the walls, they were so impressed with, like, how little mold there was, or there was no mold, even though the Bale walls had sort of sat unexposed now for a few months. Yeah, so that's kind of was my thinking, like, oh, it's great, it buys you time, but there is some better news stories. A few years ago, wildfires, like, ravaged parts of California. And so this report that was put out by the California Strawbale Building Association looks at 4 different houses, Strawbale houses, and how they fared with those fires. So this is the good news story. So I'm just going to sort of summarize, but this house here, it basically fared really well. This is the before pictures, and then the after pictures. And so with this house, like the fire was in the trees, like right around the house, and the flames came like right up to the walls and even touched the walls. And they charred that door on the left. And the intensity of the flames caused the hydraulic lime plaster to turn pink. And Michel Corvaux spoke about that, and he said that it was like the heat drew out the iron oxide impurities. But that's really like about the worst that happened. So this is a case where the bale walls fared really well. They didn't suffer too much from like flame intensity or burning. So it seems that the difference is that if your actual house catches on fire, then there's going to be so much damage from smoke and water that the whole thing is just going to be a write-off. But if your neighbor's house catches on fire and you have a strawbale house, or if there's a forest fire and you have a strawbale house, you have a much better chance at survival. Also because the forest fires were so great in California that the fire department wasn't coming because they were just putting out fires everywhere. So it was just a kind of like stand back and cross your fingers and see how this goes. So that's that house. This is another house. So kind of the same thing, the same level of damage, some like cosmetic damage on the outside. In this one, they said like the windows didn't even break, which they were really surprised and impressed by, and they attributed that to them being inset, the 14 inches, and flames tend to go like up, so they just didn't bust the windows. Pretty awesome. This house here, if you read this long email to the architect, it tells this like completely harrowing story about the homeowner and his dog waking up at 2 in the morning to like crackling noises and looking outside and just seeing like all the grass on fire and all the trees. And he tries to get self-service and there's no self-service. He can see like his shed has caught on fire and he's like, what do I do? He decides to make a run through some of the flames to his truck. He has to convince his dog that this is what they want to do, and they get to the truck. He's forgotten his keys. He has to run back to the house. He gets the keys. He gets back there, and then he has this moment of like, okay, I'm just going to flee. But then he's like, my neighbor, like, does my neighbor, a kilometer up the road know this is happening? So, do I stay? Do I go? So he starts to drive towards his neighbor's house, and his neighbor comes to him. So he's like, he said, I've never been so relieved. At that point, they do get cell service, and they call the fire department, and they're like, this is everywhere. Nobody's coming to help you. And then what saved them was that this house is like on this hill, and there's a little bit of a clearing, like the whole way around the house. So the grass burned, but luckily there was like no big trees right around them. So in the end, they made the call, well, let's just go back inside and hope for the best. And this house was not damaged at all. So the article, it does a really good job of saying like the success of these stories is in part like planning and detailing, but in part like a little bit of good fortune too, like the way the wind's blowing, the fact that there was this clearing around the house like saved this house. So then the next one, this is a pretty striking before and after. Yeah, this is like a house that is like sort of several little strawbale, I don't know if it's a house, I think it's a studio of some kind, several little strawbale cubes with then like a big roof structure on top. All the wood framing, all of this that you can see burnt, and what they were left was just the strawbale cubes. So that was pretty impressive, like even when things fully catch on fire, the bale walls more or less held up. They held up until, again, it was the top of the wall is the weakest point of the assembly. So they held up as long as, until that top plate burned. And then it left loose, like exposed, unplastered straw on the top, and then the fire got in, and the straw in the walls did eventually, smolder and burn to nothing. but the homeowner said that she thought that if the top of the wall had been plastered, that they probably would have withstood the flames like the whole time. You know, the two things that people are like really freaked out about bale construction is like fire and water, right? And actually, like the walls performed so well with both. And I think the nature of us bale builders and professionals is we're not always that good at like telling that story and sort of tooting our horn and championing that. And I think that we need to do that. And I think there is a call for like educating firefighters, and so that's a project to-do list. Yeah.
It's a relationship that we should be.
And also, like Greg and I spoke about that this week because he also said it was like the least toxic fire that he'd ever been around. And in all his years of fire remediation, people only died once, and they died from the carpet, not from the fire. Once the carpet got on fire, it's super, super hot in one breath, it's super toxic, like you're dead. So Greg was like, that was cool. I don't know if that was just coincidence. And I was like, well, I think there's a correlation there. I think that people who have Strawbale homes generally have fewer toxins. Like, well, we plaster, we still have top plates, but then we've been plastering in between the top plates with fire resistance and pest resistance in mind. But I mean, there still is, it's just 2 2x4s in the flat, so that wouldn't take that long to burn. And then, so I think really like a layer of cement board there would then be like the optimum, yeah, resistance. If we have time, I have a YouTube video at a Strawbale building conference in Europe, and the bale builders, have you seen this one? Or okay, the bale builders are like, we're going to do a fire test, and they just light a bale on fire. And then they're like, and now we're going to try and light Tom Riven's dipped bale. So he dips all his bales in clay first, and then the clay dipped bale has a much harder time igniting. It's kind of a funny video. So yeah, definitely the more, like Bruce King, a lot of the science in what I'm saying can be read in this book by Bruce King, Design of Strawbale Buildings. And you know, he says like even like in stuffing and bale walls, that would be a weak part, right? Because it wouldn't be as dense as the bale. If you coat that with clay, it's going to have a higher fire resistance. Yeah. So last April, I got a call from some people that I had never worked with before that said, we've got this like brown staining on the outside of our plaster. And it's like, oh, that doesn't sound so good. And then he sends this picture, and I look at it for a little while. And can anybody, we try and connect the dots here. Anybody see anything? I'm hearing plumbing stack.
Pretty much
yeah, it's pretty much in line. Yeah, that's what I came to after looking at that for a little while. It's like, these dark spots are right underneath that plumbing stack. And so this house was built in 2008, and at the time, the roofers did a horrible job. There's all kinds of things that are wrong. And one thing they didn't do is they never put a flashing on that plumbing stack. So you know how it goes when you cut through steel, like the hole is like this big, and then the pipe goes through, and there's like an inch or so all the way around it. So for 10 years, every time it rained, rain went right down that hole. And it took 10 years for them to call somebody. So, wow. Probably should have called a little sooner when they started seeing those dark patches. So I went with a moisture meter and drilled holes. And what I found was definitely like a wet wall, but it wasn't a composted, soupy mess. It was still, there was still some substance to the straw. It wasn't all the way gone. So on the outside, at the outside of the wall, at the outside skin, I got readings of 36.7. In this book, it talks about the safe storage limit in straw. I'm going to talk a bit more about this in a little bit, but basically, safe could be up to like 39%, which sounds high, but as a safe limit, we normally work with like 25% or under. So definitely on the high side here. And at the inside of the wall, the moisture readings were only 15.3, approximately. I went up the wall and took a bunch of these. And then I started to cut holes. So I'm going to pass this around. So this is a piece that I cut out. So you can pass that around. So it's cement lime plaster and quite thick, as you can see. And you can see from that cutout that the straw is still there. It's not totally gone. And so I'm doing this now. That was in April when I first went and saw the dark spots. And then this is in September when I actually got there to do what I'm doing here. But in May, the flashing went on. So he got a roofer to go up there and do that. And then over the summer, you could see those dark spots lightening. So we felt like we had, that actually was the problem, and we could see the wall like starting to dry out. So, so that's what the straw looked like in there, the worst of it. So it's quite dark, but yeah, it's not totally gone yet. So I cut these holes. You can see I've got my full arm in there. Yeah, I basically just cut holes. So I'm cutting holes on either side of a stud, and I was just reaching in and grabbing as much wet stuff as I could and hauling it out of there.
So it's quite contained.
It was very contained, which was impressive. Like I got it all out. Like you could see how far it went, and I was able to grab it all and just get it out of there. So, yeah. So then what we did is put diamond mesh over those holes, and then we put a tarp up just so that rain couldn't get in, and we put the diamond mesh just so that pests and stuff wouldn't get in. And then we just left it for a month. We just wanted it, whatever was in there to dry out that much more. Totally only worked from the outside. So really a pretty good, no breaking open the inside, which is pretty awesome for the homeowners. Yeah. So I come back a month later, and I take moisture readings again, and I write them right next to where the old ones were, and it's already come down like significantly. So 15 and 9. I think that looks like a 4, but I'm pretty sure that's a 9 on the outside. And yeah, so now it's back to the safe levels, and based on that, I feel that we can start stuffing it. So the reason I did the 2 holes too was so that there'd still be something, so I could stuff straw back in there. You know what I mean? And the rest of the plaster would hold it. And then just plastered it. That's 2 coats of plaster, and then we'll put in like another one. So it's a bit of an eyesore, like at this point in time. But all in all, like I think that's worst case scenario, right? Like that's a plumbing leak. It leaked for so long. That's a lot of water, like every time it rained. And it took 10 years for it to really be a problem. And then the bale wall told us there was a problem. We could see the staining on the outside. And then it was like relatively easy to fix, aside from the fact that there's this unsightly situation on the outside. This also, I should say, is the north side of the house. So it's, again, worst case scenario because it has the least drying potential. And it's also cement lime plaster and thick cement lime plaster. So again, the perm rating would be on the low side, but still acceptably permeable. So yeah, in my mind, that's a success. Like, yeah.
Did the straw like absorb all the bulk water that was coming down, or was there also like exfiltration inside, or?
No, like the stud was still in good shape. I couldn't see that it, and actually down at the bottom of the wall, I really didn't take out that much straw from that area. It was up higher. So that was good because I was more confident that, there wasn't like something unknown down below. It was drying.
Where else did the water go?
Yeah,
A
yeah,
lot of water. Yes.
yeah.
10 years worth of rainfall.
Yeah, exactly. Yeah, so basically, like bales absorb a lot of water. Like it's a big sponge. So to quote John Straub on this, again from this book, he says, a building materials or assembly's ability to store moisture is important as it represents the amount of time that can be separated between wetting and drying events before a problem occurs. So this is a really good example of that. And so why is that? Bale walls dry through diffusion, and we just happen to have this material that has huge porosity. If you think of a bale, it's porous in and of itself, right? Like there's a lot of little spaces and a lot of little places that water can go and disperse. And then if you take a look at like a cross-section of straw, then it's like another myriad of pores and little spaces where it can go. I find that kind of really neat that like this cross-section from a microscope looks a lot like that. To get it, or I think so. I find that neat that like the macro looks like the micro. Yeah. There was a bit of a smell on the inside, but then once we dried it out and cleaned it up, like the smell is gone. It was cement lime as well. Yeah, yeah. It's what keeps the bales dry from rain, right? So it reduces their wetting potential. And then you want to work with a plaster that has a high perm rating. So cement lime is acceptable. And then like a clay lime plaster just has that much more of a drying potential. Also, the other reason that these walls didn't rot for 10 years is because the chemical structure of straw is such that it doesn't break down easily, actually. When you look at like which plants can break down faster than other plants, just read about this last night, actually, that because you start to go down that rabbit hole, it's like, okay, well, what is going to happen? Like, what is rot? And so worst case scenario is the microorganisms get in there, the fungi and bacteria, and what are they doing? They're eating, right? Their spores are everywhere. When that straw gets baled out of the field, like spores get wrapped up in that bale. So the spores are always there. And they're just waiting for that right time, for the right conditions to all be present when they could start to eat the straw and then multiply and continue. But it takes like 4 things for those conditions to be present, and it's hard to compost straw. From what I read is that an ideal compost ratio of nitrogen to carbon is 1 nitrogen to 20 carbon or 1 to 50, and straw has like a 1 to 70 to 150 kind of range. So it's just harder for those little microbes to sink their teeth in. And once it does start to decompose, like probably in that picture where I'm holding that dark stuff, it's getting there, then there's a lot more nutrients in the straw that become available to the microbes and they can eat. So I sort of think about it like fermenting, like making sauerkraut, because like if you're just eating cabbage, there's some nutritional value there, but if you ferment it, there's like a whole bunch more. So straw is hard to ferment or hard to compost. So that's another part of the equation. But I think what's really important to look at here is, again, that bulk water situations is what we need to worry about, and moisture getting into the wall through air leakage, detailing windows and doors isn't a problem, but keep the water out. Like that's the thing to focus on, because like no wall is going to do well. And a bale wall will hold on for a really long time and give you 10 years to make a phone call. But people can get really freaked out about the details. Like you'll get questions, well, what about that anchor bolt? Is water going to condense there? And then like, mold. And I don't think so. Like from what we're seeing, it has huge capacity. So that's really good. And again, I think we could be better at like championing that story, because straw has a bad rap for fire and for moisture. But the way that we build the walls with the plaster skins, it actually sort of outperforms conventional materials faced with the same kind of loads.